In this video, we're going to do an example problem using the time-independent constant acceleration equation of motion. The problem is such: we have a brand new fancy car that we just bought with custom license plates. We are driving down the road at quite a clip. We're going to say that we're going at 28 meters per second, which is equivalent to around 60 miles an hour. It's about 62 miles per hour. And what's going to happen is, as we're driving along that road, a tree is going to fall into the road in front of us, 50 meters in front of our car. What we need to figure out is what acceleration do we need to avoid crashing our brand new car into the tree. As a reminder, we have the constant acceleration equations of motion. For this problem, the idea that we're going to use, the idea is constant acceleration, and we're going to use the time independent. Going from what we derived in the last video, we're just going to copy this formula here and solve for acceleration. And so the formula is v final squared minus v initial squared is equal to 2 times the acceleration times the distance traveled. We are solving for acceleration, so a little bit of algebra gives us that this is v final squared minus v initial squared divided by 2 times the distance traveled. Plugging in some values, we know that the final velocity, if we want to stop before we hit the tree, should be 0 meters per second, so 0. Minus our initial velocity, which is 28 meters per second. And we need to do this stopping hopefully within 50 meters. We evaluate this expression. We check units first. We have meters squared per second squared from the squaring here. Divide that by meters. That gives us meters per second squared. That is exactly the units that we want for acceleration. Evaluating this gives us 7.84 meters per second squared. If we write this in the proper significant figures, we get an acceleration of 7.8 meters per second squared. If we compare this to the acceleration of gravity, we find that this is 0.8 g's. And so we could do that conversion. Acceleration is 7.84 meters per second squared. We're going to multiply by 1. We have the same quantity on top and bottom. On top, I'm going to put the acceleration in units of g's, 1 g. On bottom, I'm going to put the acceleration in units of meters per second squared. The units cancel. This gives us 0.8 g's. If you look online and see what acceleration or what decelerations cars can sustain whenever you stomp on their brakes, if they have the anti-lock braking systems, which our brand new physics-based car definitely does, it's around 0.8 g's. It goes between 0.8 and 0.9 g's, and so we should be able to stop before we hit the tree, which is good because we like our new car.